This is lab 24 for honors chemistry solubility of a salt, in which we will determine how easily we can dissolve a certain amount of a solid solute in a solvent. Now, since we are at the beginning of a unit here, let me define some terms for you. A solvent is usually the larger portion of a solution. A solvent, most likely in our case, is water. And it's true in this lab, your solvent will be water. The solute, that's the thing that you're dissolving, that's being broken up into very small particles, so small we cannot see them. The solute in this case is potassium nitrate, KNO3. So you're going to be adding particles of solute, which is a solid substance, solid ionic compound, to a solvent, water, and getting it to dissolve. You're going to be doing this at several different temperatures to see how temperature has an effect on solubility. So take a look at the lab with me. Notice that this lab is particularly good at dividing up the labor. So if you and your partner share the work, each one doing different chores at different times, I think you'll find it goes much more smoothly and you won't be pressed for time for finishing. So let's take a look at what partner one might be doing. Partner one, use a marking pencil. Now these will be the wax pencils. I'll have them out on the lab benches. You can mark 4 test tubes, samples 1 through 4. Each test tube will have a different amount of the solute, of the KNO3 in it. When you use a wax marking pencil, be sure to write on the glass. Do not write there's a white label, a white painted label on the side of the test tube. You don't want to write there with a wax pencil. Write right on the glass. It's much easier to remove later. If there's already marks on your test tube and you want to clean them, just rub them off with a dry paper towel. The wax won't come off if it's wet, but if it's dry, you can rub it off with a dry paper towel. Partner one then would use a balance to measure out 2 grams of potassium nitrate and pour that solute, into test tube 1. Now notice that the masses for the solute are all given to the tenths place. Our analytical balances will take you out much further, to the 10,000th place, but you need only measure accurately, or I should say precisely, to the 10th place. And to help you with that, there will be additional balances placed at the end of each lab bench, so that almost every group will have their own balance to make things go a little more quickly. So the first partner will be measuring out the masses of each of the solute and adding to one of each of 4 test tubes. The second lab partner would be starting right here at step 5. So this up here is where partner 1 starts, and here is where partner 2 can also be working at the same time. Partner 2, you're going to prepare a hot water bath in a 400 milliliter beaker. Doesn't matter how much tap water you put in there, it just needs to be half to 3/4 full. I suggest you use warm tap water. You'll get it nice and warm and keep it there more quickly if you start with warm water. You can place that on your hot plate, starting out at the highest temperature, and then we can turn it down once it gets up to about, I would say, about 60-65 degrees. You don't want to get your hot plate too much warmer than about 65 degrees Celsius. Okay? Your hot water bath, the idea is that each test tube is going to go into the hot water bath, and as partner 1 is filling them with the solute and the water, partner 2, you can help by adding the water to the test tubes. You place the test tubes into your hot water bath and get your solute completely dissolved. Now your hot plates, you're going to need to share those with a neighboring lab group. You can probably put 2 water baths on each hot plate, so you each will have your own water bath. That way you won't mix up your test tubes with a group next to you. So you're going to have a hot water bath cooking here, in which you're going to have positioned 4 test tubes. Each test tube has a different amount of solute and the same amount of solvent. I'm not going to have room for my 4th test tube, but you get the idea. So they're in here and they're warming up, and you're going to stir them. You're going to stir with a thermometer. The thermometer will give you a sense of how warm each one is. As soon as you see each test tube in turn has dissolved, then you can remove the test tube from the water bath. You're going to need to have a thermometer in it, so you're probably going to need 2 thermometers per lab group in order to keep track of this. One lab partner will need to use a thermometer to keep stirring those solutes that are not yet dissolved, while the other partner has taken out a test tube, now has a solution here that is being stirred, and you're watching very carefully for signs of crystals. This is the key to the experiment. You have your solute dissolved in your solvent and it's been heated up. Now you're stirring and you're watching for examples of very tiny little crystals. They're not necessarily going to look like the solute that you originally put in there. They won't have the same shape probably, but little tiny ice-like crystals forming. The moment you see a crystal form, you're going to record the temperature at which that first crystal appeared. That's what's going to go here in your data table. This is the first appearance of a crystal. If you look away from your test tube and you've been stirring and you look back to your test tube and you see a flurry of snow, of crystals, you missed the first one, then you simply need to reheat until everything is dissolved and try again to recrystallize. It's not a big deal. You can just heat it up a little bit, get your solute back into solution, and then try again to catch the point at which the solute first forms. When you're done and you've collected 4 data points here for your group, you're going to report them for the class to do a class average saturation temperature, and then later, once we have obtained the class data, you will be able to plot a graph. So if everyone gets done in a reasonable time period during our class period, you might be able to start that graph, but we'll want to pool our class data for the best solubility curve that you can arrive at. So this is a lab of being careful, taking your time, and looking closely for changes inside of that test tube. It's a good lab for 2 people to do. Good luck!